Hello, in this video we're going to talk about Scott water domes. Most Scott blind head barrels used water domes. There was a period from, I don't know, it was about 1912 through to about 1918 or 20 or something, I think, where they didn't use a water dome, they used screwed rings. But anyway, so the majority of blind head barrels use water domes. And the idea of the water dome is it keeps the water in the top of the cylinders. So here's a barrel with the water dome removed. We can see the top of the cylinders, the blind cylinder here, and the water dome goes over the top, seals around the plugs, seals around the gasket surfaces, and then it can thermosiphon. Water domes are aluminium castings. We have our own casting tooling. We have these cast down in Sheffield, and we do all the machining in-house. These are quite a popular product. We sell a lot of these, and the reason is that Scots tend to have leaking water domes, and we'll go through a few of the reasons for that, what we do to fix it, what you can do to fix it, and also how to properly assemble them, because you wouldn't believe the amount we see that have been bodgeried. So the main problem we get with Scots with the water domes is that the water domes leak, and often the reason for that is that we have an aluminium water dome, we have an iron barrel, and where they fit together are on the outside we have a gasket that separates the two of them, so we don't get any galvanic effect between them. But where it goes around the plug ferrules, we certainly do. And what tends to happen is that the aluminium and the iron or the steel of the plug ferrules obviously reacts with the water that's in there, and it corrodes them. And this is a fine example of a 90-year-old barrel that's had the aluminium water dome and the iron barrel together. And there should be a land for the water dome to screw down onto around these plug ferrules, and as we can see, it's completely gone. So of course then you're trying to seal a water dome around a thread, and there's no way of doing that, so they start leaking. It also corrodes the bottom surface of the water domes, and you just end up with these, the amount that I see that are just totally bunged up with silicon sealer with people trying to get them to seal. So, silicon sealer isn't the answer, we all know that. So the way around it is that we put a new water dome on, because you can't rescue one that's corroded so far, there's nothing left but white fur. We fit new plug ferrules, and we'll show you the process. Here's another engine we've got in for repair, and this is a fine example. I haven't touched the dome on it, this is as the engine came in, and we can see that around these ferrules here, the two things that we always see, one is that this ferrule nut has been installed and removed using a punch, and we've got sealer all over the place because obviously it was leaking. So let's take this dome off, and we'll show you typically what horrors lurk underneath. First thing to note here, this is a tool I made, I hope you can see that. Now how long does it take to make that? That's 10 or 15 minutes, a bit of old bar stock, and all of a sudden we've got a 4-pronged tool that we can put in here and we can take ferrule nuts off with. I've got no idea why people insist on taking Scott engines apart with cold chisels. So I'll put the tool on here, unscrew the ferrule nuts and see what we've got. Besides a lot of sealer. Look at the state of that. There we are. Sometimes they'll pull off, sometimes they need a little bit of help. Right, we've broken the seal, and there we are. So you can see all this crud and muck, and there we are. Can you see all that lovely corrosion under there? There's no wonder this wasn't sealing, and it's just full of, as we can see, white aluminium oxide for the corrosion, and silicon sealer, and a combination of those two is not good for keeping water in engines. This has been apart not long ago because somebody's used O-rings on it. So let's take those O-rings off and place those in the bin. We've got different height gaskets on here. There's the gaskets around the outside. We'll have rid of those. Won't be using those again. There we are. And again here, let me get the camera. You can see that the plug ferrules, they're not as bad as the other one, but you can see on this side here there's almost no ferrule left. So this one will be getting new ones as well by the look of it. So this is typical, all this kind of crud and muck, and of course it causes engine overheating problems and such like. This barrel is kind of half blocked for the water flow. So, good job it's in here. This is the inside of the dome again. This is typical, this is what we usually see, and these surfaces here where it seals against the ferrule, we might be able to re-qualify those, but if it's too corroded, it'll be a new dome job. So the first problem is, how do you get a ferrule out that's been in there for 90 years and there's nothing to get hold of? So what you should never do is put this ferrule in a vise or a 3-jaw chuck or something, crush it up as hard as you can and then try and unscrew it, because you'll end up breaking the barrel. So there's two methods. One is that you can take a hacksaw blade and you can try and cut through the internal threads on this on both sides, crush it in, and then you can remove that. If you're a masochist, that's the route that you should take. The other way of doing it is the route we use, which is that you weld an old car wheel nut onto the top with a lot of heat using a MIG. You then get a breaker bar and a socket while everything's still nice and hot. These ones used to be in this engine here. You get a breaker bar on it while everything's nice and hot, and you pull on the breaker bar and they come out. So these are the two. You can see I've welded the nuts on those, and by doing this obviously we're not risking damaging the internal threads in the barrel, and it means that the barrel surface and everything else is untouched. So that's our preferred method. So once these have been removed, we can screw new ones in. So all we do is clean the threads up and the surface with a thread file, hold these in a 3-jaw chuck, Loctite retainer on them, screw them down, make sure they're seated properly between the barrel and the bottom surface here, because if you don't do that you'll get leaks of combustion gases into the water, or even worse, water into the combustion chamber. So you can see on this that we've refitted new ferrules. This is a barrel that hasn't been done. Here's a barrel that has. We've got the new ferrules on there, and we can now try the water dome on. So here's our barrel, and what I'm going to do here, I've got the new water dome. What we need to do is we need to set the height for the gaskets. We do different gaskets, 1.5 and 2 millimeters thick. Every barrel's slightly different, being a Scot, and obviously they've been made over many different years. So the way we go about working out what gaskets we need is that we have a standard O-ring that sits over the plug ferrule like this. We put the dome on, take the ferrule nuts, take our ferrule nuts here, there we are, we stick those on there. We use our tool that we've made, because we all use tools, don't we, instead of chisels, and we will nip these O-rings down. But you notice I haven't put any outer gaskets on at this stage. Right, so I've nipped those ferrule nuts up now, and what we've got is we've got a gap all the way around the outside of this dome. So we know it's sealed down onto the O-rings in the centre, so what we need to do is we need to use whatever gaskets in order to get this to seal. And the idea is that we want to end up with about maybe a 10th thou nip, quarter of a millimetre, 10th thou nip on these gaskets that sit on the outside. So by getting this down like this, what I can now do is I can take my vernier and I can measure the gap between the dome and the barrel in 3 or 4 different places, and that will tell us what thickness gaskets we need, and if we're lucky they're the right size. So that's 2.04, 1.85, 2.3, 2.05, 2.3. So unfortunately what we've got here is that this has fallen. Obviously if I put a 2mm gasket in this, it's only going to touch, it's not going to nip down, and the 1.5s are too thin, and if I put 2 1.5s in, that gives me 3mm, which is going to be too much. So what do we do about that? Well, the simple answer is that we can take this off now, and we will fettle the land on the dome so this sits down about 1/4 mm more, and we'll be good to go. So this is the land here that the dome actually sits on outside the O-ring. So if we just take, in this case, 1/2 mm off here. If you don't have a milling machine, you can do it by dressing it by hand. It doesn't need to be super accurate because it's the O-ring seal that's actually sealing. So we'll take 1/2 mm off that, the dome will sit down, and then we should be good with 2mm gaskets. So I'm just going to stick this in the milling machine because that's what I use for doing this, and then we'll try it back on. So I've just taken a little bit off here, off these 2 lands, so we'll assemble this back up, measure it again, and hopefully we're right in the sweet spot for gasket thickness now. Oh. There we are, that's those O-rings nipped down. So let's do our gasket thickness measurements again on the gaps. Yep, we're about 1.8mm round there. So my 2mm gaskets, which I've misplaced. My 2mm gaskets should be just the job. So we'll take the dome off. We'll use some gasket sealer, flange sealer around the corks, and a little bit around the O-rings as well, just to lubricate and make sure everything sits down. Assemble this up, leave it for a couple of hours, and then we'll pressure test it, make sure it's all airtight, and this will be good to go back to the customer. So we've got our 2mm gaskets. Going to use some Loctite 574 flange sealant. So I'll use this, or sometimes I use the green flange sealant from Worth. They're pretty much the only 2 products I use for sealing stuff up. I don't use silicone, and I don't use cheapo flange sealant because it's just not worth it. The amount of effort you put into this, and you may as well just get it right. What I'm looking for is I nip it down. I just want to make sure there's a squeeze of the sealer comes out all the way around. If it does that, we know we've got hold of the gasket and our measurements were correct. Yep, that all looks good, so we'll clean it up and then we need to leave it for the flange sealer to go off. And the last job is that we'll pressure check it with air. We'll put compressed air in, make sure it holds air pressure, and then we're done. Well, time to pressure check this. So what I do is I've got these pipes and bungs made up, so I just block off this one here. I've got this one here with a car Schrader valve fitting on it. Unfortunately the customer didn't supply the drain tap with this, so I'll stick my finger over the hole. And all we do, simply plug this on. I'll stick about 10 psi in and we'll just do a leak down check, and I'm going to stick my thumb over the hole there for the drain plug. So I've just put 10 psi in this and I can look at the gauge here and I can see that that's holding. And if it'll hold 10 psi, it'll hold water at 0 psi. So that's it. We'll take these pipes off. This is good to go to the customer. The last thought on water domes and pipes is that obviously these go together with cork gaskets, and I would always recommend that once a cork gasket is wet, that you keep it wet. So run antifreeze. Don't use neat water. There we are. Don't use neat water in your Scots, because there's plenty of Scot blocks are cracked because people have done that. Run antifreeze, and once it's wet, keep it wet because it stops the cork gaskets drying out. Once they're wet, they like to stay there. So this is it. This is good to go. And that's how you put water domes and fix leaking water domes on Scots.